Start பண்ணலாம்.
You can start. Yeah.
In order to create an engaging learning experience, the role of the instructor is optional, but the role of the learner is essential. Good evening to everyone. I am Dr. R. Shanti Devi, Assistant Professor on behalf of PG and Research Department of Geography, Bharati Women's College, in association with the Center for Remote Sensing, Satyabama Institute of Science and Technology. I welcome you all for the second day webinar program on issues, challenges and technology in water resource management. It's my pleasure to welcome today's speaker, Dr. R. Srinivasan sir. Welcome, sir. He did his graduation and post-graduation in geology from the University of Madras. He also did his one-year postgraduate diploma in remote sensing from Anna University. After completing his education, he joined the Tamil Nadu Water Supply and Drainage Board and worked for about a year in locating groundwater resources, Arani, Vellore areas of Tamil Nadu. Then he joined the Geological Survey of India and worked in many parts of our geology. He was associated with major remote sensing and aero geospatial data integration project called Vasundhara, which was the collaborative work between GSI and ISRO. Then later on, he was deputed to the Department of Space as a scientist SD at NNRMS RRSC, Jodhpur, Rajasthan for 2 years. After coming back to GSI, he was associated with a major effort of mapping the entire Tamil Nadu coast for geo-environmental aspects. He further worked along the Tamil Nadu coast for glass, sand exploration, seismic studies, engineering geological studies for power and infrastructure projects, tsunami studies, etc. He retired as Deputy Director General at NER, Shillong. He did his PhD also in the University of Madras, focusing on natural hazards susceptibility of Tamil Nadu coast. He serves as a member of some of the scientific committees of Tamil Nadu. Thank you, sir. Thank you for accepting our invitation for this webinar. Today's theme is potential and problems of groundwater scenario along the Tamil Nadu coastal plain. I hope that it will be very useful to everyone. Thank you, sir. Thank you. Sir, you can continue, sir. Srinivasan, sir?
Yeah.
Yes, sir. Welcome you.
So I sincerely thank the organizers for providing the opportunity for such a vital topic discussion. So I made it a point of giving some basic knowledge to, particularly to non-geology, the viewers and the students. Maybe quite a few geology people may be there. Still, I assure you, it will be a very colorful and interesting journey all through the Tamil Nadu coast from the groundwater point of view. So, can I go ahead with the presentation? Hello?
Yes, sir. Audible, sir. Please. You present your presentation.
Can I go ahead with the presentation?
Yes, sir. Yes, sir. Sir, are you hearing?
Yeah, I am hearing. Can I go ahead with my presentation?
Okay, sir. Okay.
All are in.
Yes, sir.
All are in.
Participants
Can I
are
go
in,
ahead
sir.
with the presentation?
Yes, sir.
Yeah, my voice is audible.
Yes, sir. Okay, sir. It's perfect.
The screen is visible?
Yes, sir. Everything is perfect, sir. Share your PPT, sir.
Yeah, thank you. So the today's topic will be on the potential and problems of groundwater scenario along the Tamil Nadu coast. So it is as given in the the picture below. It is a problem of the vital resource groundwater for the our basic survival. The நீரின்றி அமையாது உலகம். So the water is the sustaining factor behind our basic living itself. Is plenty in somewhere. It is totally becoming scarce and becoming dry in somewhere. So we live on top of the surface and we do not understand the inherent complexities and the system involved in the groundwater occurrence and movement. So today our main job will be in understanding the basic aspects of occurrence of the groundwater and its associated quality and quantity along the coastal Tamil Nadu I have taken. So it has its interesting aspect to discuss. I hope all you will enjoy and we can discuss all the questions in the at the end of the lecture. So the basic definition we will run through. Groundwater is the one that seeps through the rock and soil and is stored below the ground. So the rock which the groundwater stored are called aquifer. The aquifer definition is the one where it is a repository or storing medium of the groundwater below the earth's surface. So it is a mostly extracted natural resource and its availability is granted, it is taken for granted by us without knowing its replenishment. We go on consume. Our need is increasing, we are ever expanding. So India is the largest user of the groundwater. The groundwater table have been continuously dropping. That is the fact. That is the caution or alarm we have to do. So the survey by the Central Groundwater Board and all that in our country, it is 64% of the wells are showing decline in water level. Water level is ever going down, and but it is to be recharged or replenished. The climate is changing, altering the monsoon pattern. Some year it's raining very heavily, then successively there will be drought. Like that, it is not getting recharged. So over exploitation of the groundwater has created serious problem. So this some basic this one. So now you understand through this. It's a very basic diagram of hydrological cycle where it is raining and snow melt runoff. Water is penetrating into the ground through the river and streams. Then some water is going back to the ocean, and the ocean water getting evaporated. So it is forming cloud, and this water seeps into the ground also. There is a flow like a surface water flow. There is a flow at the underground also. So what any water resources management, there is a surface water and an underground water. Surface water it is used for the we construct the dam, use it for the irrigation and for the other piped water supply. So like that, but groundwater is also as its flow, it has to be managed. The management of the groundwater, particularly. Hello, hello. ஷேர் பண்ணிட்டு தானே போயிட்டு இருக்கேன். ஹலோ மேடம், ஷேர் பண்ணிருக்கேன். இப்போ ஷேரா இருக்க பாருங்க. ஓ, அதை குயிக்கா நீங்க அப்படியே சொல்லிட்டு இருக்கலாமே. I have gone through 10 slides. Now is it okay? Are you seeing? Hello? Now the screen is shared. Are you able to see? Hello?
Yes, sir, sharing app, sir. Sir,
Hello, madam. The screen is shared. So can we go ahead? Yeah, yeah, you tell me quickly. Otherwise, I was not really. When we go for a full screen, I cannot see the Zoom. Now it's okay. Okay, I will start from the beginning. So today's topic is the potential and problems of the groundwater scenario along the Tamil Nadu coastline. So, we live on the surface of the earth and the number of earthen formations below through which the groundwater seeps and it is being stored in some of the soil and the rock formation. So on top of the surface, we do not much appreciate or understand what is happening below. So the complexities involved in the groundwater occurrence and movement and its utility at the subsurface. So it is a problem of plenty in some places. It is totally scarce or not being available in plenty in some other place is to be discussed today. So, some of the basic key points we will run through. Groundwater is the water that seeps through the rock and soil and is stored below the ground. So, rock that is stored is called the aquifer. Is it okay, madam? Hello?
sir,
private box.
Hello?
okay, sir. Hello, sir.
Can I go
Okay,
ahead?
okay, sir. Okay, sir.
Audio and video,
Audible and
okay?
visible, sir. Audible and visible, sir.
So, I will go ahead.
Yeah, sir. Go ahead, sir. I will tell you whenever starting, sir.
Okay.
Thank you, sir.
Some of the basic definition we will run through. So today it is a colorful and very enjoyable journey all along the Tamil Nadu coast. From the groundwater point of view, it will be conveyed to you. So I oriented these to mostly non-geological, audience and the people, even though quite a few geological students may be there. So the importance of the whole groundwater occurrence and the movement will be conveyed in about an hour's time. So some of the basics we will run through now. So groundwater is the one which seeps through the rock and soil and stored below the ground. It is stored below in the. It's called that whole area is called an aquifer. Then it is a most extracted natural resource and it is availability is taken for granted by us. We do not know how much it is getting replenished. We go on extract. So India is the largest use of the groundwater and groundwater table has been continuously dropping. That is the one because we are ever using for industrial, domestic, agricultural. There is a plenty of usage. The basic survival medium. So நீரின்றி அமையாது உலகு. So groundwater is the basic sustenance aspect. Water is the most valued commodity, but uh, because of that, our over extraction and the usage, the central groundwater study says it is 65% of the well should decline in the water level. So as the climate is changing, it is altering. There is a less rainfall continuously, and there is suddenly more rainfall, particularly. So the monsoon is also playing havoc. So there is a recharge problem. It's always there. So the over exploitation is always taking place because of the urbanization and ever increasing agricultural activity. So, what is in the vessel is insufficient for our eating or drinking. Our vessel contain going on the less and less water. You understand the crow and the pot story? where the crow will put a stone in the pot and eat the splashing water. Like that, we are now digging deeper and deeper and deeper. So it is a basic hydrological, sketch which says how from the mountain snow melt runoff from the rain, the water gets into the underground system. There water resource always a surface water resource, groundwater resource. A river, streams and all flowing, we automatically try to use the surface flow water also by constructing the dams, canal and other piped water supply. So the supplementing effort is by the underground water which get its water through from the surface resources also. So there is a monsoon, the overall rainfall factor, the Tamil Nadu stands in between with some 120 to 140 mm. So 110 to 120 centimeter rain is there. So if you see all India rainfall data, so whatever the rainfall that is happening, it gets into the pores and openings into the, it goes through the soil and into the rock, into the fractured rock and into the subsurface medium. So the water holding medium strata. Now let us see how fresh rock is weathered, how it is altered, how it is continuously eroded by the the regular physical and chemical weathering process as well as by the rain. So the fresh water is slowly converted into a weathered rock. Like a human being, rocks are also in the due course of time by aging. There is a withering and weathering. You see in the this slide how this kind of fresh rock slowly becoming partly weathered. Then it is more weathered and is becoming a more or less in the powdery stage. Hello. Sorry. So the water will become more or less a soil. From a fresh rock to the soil, it is weathered into a number of places. Now it is a fresh rock, into a slightly weathered rock, moderately weathered rock, highly weathered soil. So why I am telling is, more it is weathered, there is a more groundwater potential. The rock which is occurring below the surface, if it is more powdery, more weakened, more it is in an unconsolidated state, it can hold more water. Then apart from its own physical weathering, there are number of cracks or joints or fractures, like our the palm fingerprint. The rocks are completely broken by the earth process, by the tectonic activity. The rocks. So why this is also important? In apart from weathering, the water seeps through all these cracks also, which is stored in subsurface medium. More the rock is fractured, more is important from the groundwater potential point of view. It can store more water. So the water bearing material which I showed you in the previous slide, the fresh rock, a massive one will become unconsolidated. So the geological medium below the ground, below the at the subsurface, they will become very loose too, and some are remaining and very hard also. So the two characters are important: the porosity and permeability of the rock. A water bearing capability strata. The water bearing capability of the subsurface strata decides how much water it occurs there. Whether it's a urban area, coastal area, rural area, hilly area, what is the water bearing capacity of the subsurface strata? So whether this area will hold water or not is $1 million question decided by the subsurface medium. So the porosity is the expression of the white phase, and the permeability is to transmit the water. So water also flows underground, like a surface river flow. Water also flows underground. The sands and gravels are the most important aquifer. The movement of water in sandstone is controlled by its permeability. So, for example, I am telling, so joint, fracture, bedding plane and all will be there, that we will see next video. But some are impervious, some formation and below the surface like a silt, clay and all that, they do not have much pore. They are not that pervious. They are impervious. They don't hold much water. If the clay area, their water potential will be less. So the rocks have different porosity and permeability. So each area is a different kind of rock and different with a different grade of porosity and permeability. So definitely the water potential will change from area to area. So certain conditions favor the accumulation of groundwater in the aquifer. So every rocks are, like it is folded like a basin, and there will be lot of weak plane. I already told you such feature focus the accumulation. They are the accumulating point. So in the, all along the underground subsurface formation, some have the accumulating point where we will drill and take it. Like oil accumulation, there is a water accumulation also will be there. So the hard rock of aquifer is limited. If the rock is very hard, it is a limited potential. So if the depth if at the below 60 meters below and all that, the rock is more or less massive. More deeper will go, the underground rock will become more massive, and there will be less intergranular space left. There cannot be much transmission. So it is a more, we think we by drilling more deeper and deeper we will get lot of water, but by going deeper and deeper the rock is more massive, there will be lesser joints and fracture, lesser pores, so our chances of getting water may not be that good. That's the point conveyed here. So I told you this is a kind of a basin type where water will accumulate here, or the kind of a bedding plane, or the horizontal fracture, the water will seep through. You see some kind of these are the natural the fault or a crack type system in the rock. All these are important of the water. You see the complete jointing of the rock here. Now your camera is kept inside the well, how the water is jetting out through the cracks in the rock. This is particularly more important from the hard rock area, in the inland area also. So it says conveyedly through the cracks and the weathered medium, the water is flowing into the well. A cross section, it says so much of fractures and all. The water movement, the movement of groundwater through the fractures. So the borewell is drilled, the borewell meets the fractures. So this conveys clearly how important the rock is fractured and porous. Now, a basic system of from the mountain, the river starts going. Now we will discuss along the a kind of a coastal plain. These are coastal plain, a delta type. The river from the mountain, it brings the water and it gets into the underground system also. So now the saturated definition of the aquifer, I already told you, the saturated zone beneath the water table is called an aquifer. And the aquifers are huge storehouses of water. I already told. Now there are three kind of aquifers will be there. This blue line, kindly watch. This is the water table. Water table is nothing but the level of the water. When we see in the well where the water stands, it may be 3 meter, 5 meter, 20 meter. So this is the table indicating the level of water from the surface. Now below the water table is a saturated zone. Above the water table, unsaturated zone. Now in the water table, there is we see the subsurface soil and the rock formation. It is not confined. It is open to the earth surface, and is called a unconfined aquifer. This where we can drill and take it. But there are, you see this blue where it is a what the porous and permeable the geological formations are confined between one tight or impervious formation here and another impervious formation. This is called a confined aquifer. This unconfined aquifer, confined aquifer. This confined aquifer always under pressure because it is held tight between a bread and above that some butter. So we get some clay formation or impervious formation above and below. Then above that, totally in the coastal area, in a sandy area, we get some perched aquifer where some on the top there will be floating lenses of water. So that also being dug, we normally in the beach and all that, we put a small well, children play, take out, they are all perched aquifer. So normally for our industrial, domestic and agricultural purpose, we use this unconfined aquifer and the confined aquifer. So water, when it occurs in the confined aquifer, it is called artesian well. Artesian well, so water flows automatically by pressure. So when we put a borewell, there is a self-flowing wells are there. Now, there are two kind of aquifer in the part. This is aquifer map of the overall India. The aquifer always says it is a hard rock aquifer. For the Tamil Nadu and Tamil Nadu coast, we will see here there is a blue color hard rock aquifer and a kind of a unconsolidated aquifer. So normally we will see all those things later in the later slide. Now about aquifer we saw. Now what are the procedure to fundamentals we have just gone through. Now, what are the procedure to groundwater study? Yesterday also there was a lot of question how to locate a groundwater, sir, what was scientific manner. So initially we have to do a hydrogeomorphological study, then a geological study, a geophysical study to locate the water. The remote sensing and this one is a basic tool. It is the most essential also to locate the possible areas of the groundwater, but it should be followed by a good ground geological method and the geophysical method. Now, the modern geographic information system tool has come, which analyzes the multidisciplinary data like all these 4 5 geological information, geophysical information, geomorphological information, etc. So, by the geographic information software, we analyze. We may narrow down the target area where to drill and get water. We drill it. So, objective is to locate the potential zone. Now the geomorphology, let us see how, because you are all mostly geographers, with the role of geomorphology in the groundwater, the potential point selection, let us see. So it is a process, structural process by weathering, erosion and transportation, all the material, various kind of weathering and various kind of landforms are there. So not all landforms are, some landforms are good for the groundwater point of view. So hilltop, let us say, it may not be that important, but the slope of the hill like a pediment, then there is a plain called a pediplain, then the alluvial fan, the rivers come and drop the entire load of the material. These are all then the paleo channels and all that. Some of the landforms are so by using satellite imagery and the ground method, the geomorphology, we have to locate where are the alluvial plan, where are the buried channel, where are the pediment, where is the pediplain, that we have to locate it. Now, when the river cuts through, it gives some older paleo meander or oxbow lake. Then it has a terrace also. It is cutting its own from the hilltop to going deeper and deeper. So we have to map correctly all the geomorphological aspect, and satellite imagery is one such tool to mark all the paleo channel and the rock formation and the morphological or landform aspect. Then in addition, the crustal weak zones are lineament. The lineaments and the crustal weak zones are important. I already told you the rock content more fracture important. Though the satellite imagery of the entire Tamil Nadu coast, more or less most of Tamil Nadu coast, I have kept it where it is bit feeble. The black color lines are the lineaments or the crustal weak zones are the fracture. We will map it through the remote sensing imagery. We will by normal visual interpretation and also by the image processing technique we can look at the fracture. Now this example take you, this is a one river but it's a old river course, paleo river course. Because why it is important, this also contain the sand and the granular material. Riverbed contain the sand, it is good for holding the groundwater. The old channel also contains the granular sandy material. If you drill there, you will get the water. So it is a critical lies in the groundwater investigation. Hydrogeomorphology is not a geomorphology applied to the hydrological factor and the groundwater point of with respect to the occurrence of water with respect to landform. So we look at the cut-off meander, sand ridges and all that. So field investigation groundwater. So when we do this kind of geomorphology, the field we cannot run around the entire area. So restricted area, once we restricted by geomorphological method, we can restrict. We can go to the ground, map the area for geological condition. Then we can drill also. A geomorphological basic map to be created. Kindly understand all the viewers and the students. For any scientific activity, a plan or a map is needed. So a basic, particularly geographer can prepare a very good geomorphological map. A geomorphological map is helpful in selecting the groundwater potential and the other area. So a map to be prepared with a sample geomorphological map. It is I am showing you where it's showing all the landform unit, the pediment, pediplain, and all the other unit. From the groundwater point of view, we can categorize also which has got a good moderate potential. Now the geomorphological map is overlaid with the drainage pattern. The drainage density is important. How much the groundwater potential point of view. Then the lineaments are superimposed. So two or the geological theme will be there. So all the themes are superimposed one upon the another. The drainage, the lineament, the geomorphology and geology. So this is a basic geomorphological map with all the other data. So we are now layering one after the another. The geomorphology, lineament, drainage and rainfall factor, slope. So multi-thematic layer Yesterday, some of you were asking about that. So the maybe tomorrow also you may learn a little bit on this. So the present technology is to use a multi-theme data, and this all will be overlaid and analyzed in a digitized form. All this map I showed you, they will be digitized, converted into a vector and raster. Then they are all overlaid, and it is to be analyzed by a number of methodologies. That the analytical hierarchy process where these are the controlling factor: geomorphology controlling factor, lineament controlling factor for the groundwater occurrence, for the groundwater potential area selection. Now drainage, slope, rainfall, this controlling factor to be given a ranking. The factor and parameter are to be ranked by the known knowledge. Then they have to be statistically correlated. Then every area, every pixel to be given a kind of a mark or a ranking based on the its weightage. In some area, if the more fracture lineament is very high, some of the pixels and lineament, it will be ranked very high. If the geomorphology is very favorable, like some paleo channels and all there, it will be given a high ranking. If it is a massive and bland area, it will be given a low ranking. Like that, in this hierarchical ranking, we can work out a overall marking system or a grading system and come out with a kind of a zonation map, a zoned map we will get with a very poor, moderate, good, very good, a potential map. For example, Chennai city or the other one, we can take which area is good groundwater potential, moderate groundwater potential, poor. The ultimate, the geographic information system output. So, or the even visual interpretation output. So, this is done after remote sensing study, after a ground geological study, etc. Then once we arrive at this map, we have to prepare like this zonation map. Then we can do some geophysical resistivity testing, because that cannot be done for the whole area. Only for a prospective area, in a very good and good area, we can do some geophysics. Then we can drill. Ultimate step, drilling is very costlier. So this whole exercise of the remote sensing GIS and all to narrow down the target. No, with the more or less your mind would have been set what is important for the groundwater occurrence point of view. So porous and permeability, how to search the groundwater we have just saw. Now let us go into a coastal plain of Tamil Nadu. How the whole scenario is there, we will rush through, and it is in an interesting way. It will be presented to you. So coastal zone, it's coastal plain. It is a area where up to which the marine influence is there. It is a sea and the adjoining area up to which some influence it is there. For example, Chennai means up to Pallavaram or little bit beyond, or up to Sriperumbudur, it will be a coastal plain. So from the seashore, 20 to 30 kilometers, or in some area it may be even 5 to 10 kilometers, it will be a coastal plain or a coastal zone. So each coastal zone all along the coast, all along the shore, we will get that, and they have their own vulnerability, and because of the population density and urban agglomerate, there is a competition to use the coastal plain area. Coastal zone is now lot of activities are there, so there is a plenty of demand for the groundwater is there. So we will run through now what are the coast in the coastal plain of the Tamil Nadu. This is a geological map. What is the basic geology of the all along the coast only? But let us start from the northern side in the Chennai. Chennai, you will get this kind of. Kindly carefully watch. Now we are entering into the interesting phase of the whole lecture. The Chennai area, particularly now with the up to Mahabalipuram, they are a little bit from the even northern side, Pulicat Lake to the Mahabalipuram side. In the northern side, we get this kind of hard rock. Okay, these are all called very old rock. They are very old, from 2000 to 2500 to 3500 million years. Geological ages are in million, not in our age is only in tens, 60 years, 70, 100 years. Rocks are in millions of years. Now, part of Chennai is covered with this kind of very hard rock. Then another part of Chennai is covered with this kind of sedimentary rock. It is called is a Gondwana rock. So it is also very old rock, some nearly 120 million years old. So the Chennai and the surrounding, we have this kind of hard rock and this kind of sediments. Pallavaram and Gindi and Adayar, you have this kind of hard rock. In North Chennai, we have this kind of slate, shale, this kind of rock. And these two are covered by this kind of sand and clay. The top, these are consolidated formation, and they are covered along the beach. You would have seen some loose sand and sediments are there, dunal sand. They are younger. These rocks are older, and above which you get some younger sediments. I am showing you below. Kindly watch my mouse arrow. So I am taking the mouse arrow. So it is there. Now next comes when we travel like that. Then in the Kadalur and Pondicherry area, we get some. You would have seen whomsoever got to Pondicherry and all that. A red colored, a plateau type, Araval plateau and all that. You get another type of sedimentary rock, sandstone, mostly a sandstone rock you will get. Then up to Kadalur, you see Kadalur, Trivandhipuram and all that, you get that kind of a sandstone plateau is there in the Neyveli area also. Then again, when we travel down south, geologically, we will get into a deltaic type, where Napatnam and further down south, all along up to Ramanathapuram, surfacially, we will get deltaic sediment, delta sediment because of Kaveri flowing. The kindly watch my cursor mouse. The mouse I am taking to explain the concept. Kindly, all the viewers, kindly watch the mouse. So these are the deltaic basin, which are the deltaic silt, sand and clay, but they are only superficial. Below which again you will get this kind of sediment. This kind of sedimentary rock, a sandstone rock and some limestone rock are a deeper depth. When we want groundwater, we have to drill through the top sediment and into the deeper hard rock also. So when we go down south in the Ramnad area and all that, in the Rameswaram island we get some calcareous sediment because Gulf of Mannar, Coral Island, lot of calcareous material is there compared to the Pog Bay and other Bay of Bengal. Here calcareous setup comes and you get some calcareous sandstone and other rocks. Then black cotton soil is there. Then when the down south you get a very deep red color, there is sand. That is a red color sand also we will get, and hard rock again comes. So you get this kind of massive hard rock in the northern part of Tamil Nadu. Then in the central part you get a deep sedimentary part. Then again in the southern part you get the hard rock. So hard rock, the crystalline rock or igneous and metamorphic rock are there in the southern part of Tamil Nadu coast and in the northern part of Tamil Nadu coast. Centrally we have a thick sequence of the sediment. So that is how the geology is there. So in the geomorphology, just rush through, it will start with a hillock and then the hill slope, a pediment, then the pediplain. Then you get into it, slowly get into it from west to east we will see. From what is the basic geomorphology of the coastal plain, Tamil Nadu coastal plain, west to east, western side you have denudatial and fluvial. You get Inselberg plateau, kindly watch my mouse cursor. So the western side, you suppose the Chengalpet or in the Bellavaram side or on the other little bit when we go from west to east, we get the Madurantakam and all that, Inselberg plateau, pediment, pediplain, more of a fluvial type we will get. Then slowly it comes to the alluvial floodplain. When we come to the east, you get to a marine setup. Eastern coast, eastern side, you have the coastal dune, your coastal clay. So from the fluvial hillock and the plain, a floodplain type, here the floodplain type, then we run into a coastal system, a coastal morphology, coastal landform unit, like a barrier dune lagoonal complexes we get. So for example, this is the sea. On the coastal side, we get some dunes, coastal dune. We all know the East Coast Road. The East Coast Road, this is the East Coast Road, a conceptual diagram where you get a dune. On the dune itself, the road run. Then adjoining further, the west of that, where the Buckingham Canal got, they are all called tidal flat. Where clay is the medium, here sand is the medium. So again you get in, again parallelly, Old Mahabalipuram Road, it is again on the coastal dune. So alternating dune and lagoon, this is a morphology. This is the Buckingham Canal, a tidal flat scenario. So this will be more saline and salty. This has got a potential for the groundwater. This is not potential. A geomorphological block diagram showing how from the hill to ocean the geomorphology is there. So we saw the geology, we saw the geomorphology of the coastal plain. Now from the groundwater point of view, what is the disposition of the groundwater in this coastal sector? We are classified, we will see. So we have got the Now, already I told you aquifer. Now we have to always tell in terms of aquifer only. What is aquifer in Chennai? What is aquifer in Mahabalipuram? Aquifer in Pondicherry. Technically, the storing point. So along the coastal plain, we get water in the aquifer in the hard rock area. I told you. So I will rush through. We did not repeat. Also, your older sediments will be there. Then younger and recent sediments will be there. So the younger and recent sediments are closer to beach and adjoining area, where loose sand, granular sand, and other silt, the floodplain sediment are there. When we go further away from the sea, we get the hard rock and the sediment. So mostly wells are in the. I told you already. You kindly remember the old slide. The unconfined aquifer in the and the confined aquifer. In the unconfined aquifer, which is exposed to the surface itself, no confining medium, we pump through, we put a well and take it. So you see this one. But in the confined aquifer, it is automatically self-flowing. Artesian well will be there. This is also occurring along the Tamil Nadu coast. So hydrological setup. So we get in the consolidated water bearing strata. So we get the marine clay, silty clay, and weathered and fractured rock. So where the water along the Tamil Nadu coast, it is in the weathered and fractured rock and in the marine sand and silty sand. So shallow depth to a deeper level. So water after some depth in the granular zone, it will become saline and saline when we go deeper. So some of the even deeper sediments are also marine sediment, which we'll see later also. Now a broad hydrogeological, because we are dealing with the groundwater setup of the Tamil Nadu coast. The whole with a very large area, very regionally and very broadly, we can divide the entire Tamil Nadu coast into Chennai to Palar area, Palar to Pondicherry, from the Pondicherry to this Adramapatnam, then Adramapatnam to we can take up to Tuticorin, and Tuticorin to Kanyakumari. So 5 segments I have divided based on the hydrogeological setup. Each is unique. Each has its own potential. Each has its own problem. So now the first one we will take Chennai to Palar. How the situation is there from the groundwater potential column. Just 2 or 3 slides. We won't go much into the detail. We will quickly cover. I already told you Chennai to Palar through the Mahabalipuram and all that. Palar river is near Kalpakkam. It is ending. So Chennai all through the ECR, OMR and through up to Kalpakkam and up to Palar river, the hydrogeological setup is something like that. So we get the archaean or the very old, geologically it is called a very old metamorphic rock at the base level. Then we get some sedimentary rock called a Gondwana rock. And they are covered with the marine and the fluvial sediment. So unconfined aquifer only is there. So Chennai to Palar unconfined aquifer and limited yield, moderate yield only we will get. No great potential. So now let us see. In the Chennai how the scenario is there. This is everyone's interest. What is the groundwater situation? What are the water bearing strata in Chennai? So let us spend some just 5 minutes very quickly. We will rush through the Chennai scenario. So this yellow color, this unit, this is a Chennai hydrogeological map or geological map. I have put it. This is the sea. This blue color, kindly mark my cursor. So this is the this unit parallel to shoreline up to little bit inland in the North Chennai. This Thiruvattiur and all the Rayapuram and in the Presidency College, Queen Mary's College, all along the coast, you get some coastal sand and the clay, but below which you get some hard rock. Old metamorphic. You see this picture. You see this picture closer to coast in a north-south linear way. On the top you get some sand and clay. Below some hard rock is there. So if we drill, we have to drill through like that into the hard rock. In the near central station, 25 meter, when we go 20-22 meter, we get this hard rock. So in Thiruvattiur, Vanarapete and all that, nearly around 20-25 meter, we get this very in the patta, the black colored Chornakite rock. We'll tell. So the potential, what I am telling, is bit less. Only the top, sand and all give some yield. If it is very fractured, This hard rock also gives some data. On the southern side, in the Adayar, Gindi and other places, this hard rock, you see the lower diagram where it is a bit feeble. It is the rocks are completely exposed in the Gindi, Adayar and all that. Here the hard rock is covered by sand and all that. Here is a very less amount of floodplain of the Kuvam and Adayar, particularly the Adayar river. Southern side the rock is more. So the Chennai is very rocky on the southern side and on the eastern side. Rocky in the sense very hard rock of unbreakable massive rock and fractured and all that. Now when we come in the western side, we get some sedimentary rock in Chennai. Where here the sedimentary rock called Gondwana rock, these are called shale or a little bit of silt stone, particularly in the Ambattur, Korattur, Perambur side, we and in the Coimbatore area at the subsurface, when we go even some 5 to 10 meters below the alluvium, we get into this kind of watch my cursor plane, this kind of sedimentary rock, shale or slate we will get it. So they are also fractured like that. People are putting a borehole and taking the water in this Gondwana shale, only this sedimentary terrain. So half of Chennai is in the watch my cursor. Half of Chennai is in the sedimentary strata. Half of Chennai in the hard rock situation, and both are superficially covered by river alluvium and sand. So the potential is lower only. It cannot give a very great scope of water. So because the Gondwana shale is also shale and siltstone do not hold much of the water. This hard rock also, if it is fractured only, it will hold water. So the Chennai situation from the groundwater scenario, it is not very well endured. To some extent, we are managing. Now you see a section along for the Chennai, this kind of sedimentary rocks are exposed on the western side in the Coimbatore and in Ambattur, Perambur and all that, Vadapalani, etc. This shale and sandstone will be there. On the eastern side where you get some Charnakite, this kind of hard rock, they are weathered a little bit. Then again you get some marine, these two are the marine sandy clay and sand. So this is the top cover, beach dune, then below some clay, then weathered rock and a rock. Now we are drilling through this. In this diagram, we are drilling through this medium and get into that. So kindly understand the scenario of, what is the subsurface one? Any groundwater potential? What is the subsurface situation? What is lying below our foot? What is lying below our house? Each area contain what? Without understanding the complication, we are continuously extracting whether it is fit to give the enough water we need. So industrially we need more water, agriculturally we need more water. So for example, the South Chennai Velachery and all that beyond Tiruvanmiyur, it is a coastal lagoon and saline area from Kovalam to Velachery. Completely saline. The mangrove plants are there. It is a tidal flat area, active tidal flat from Muthukadu, seawater enters. And you see the urbanization, so much of flats and complexes are coming and all that. We drill in this saline clay only. How it will give water? Particularly South Chennai, Velachery and further south up to Kovalam and all that. It is a totally saline flat. A lagoonal area, a paleo lagoon and active lagoon, we don't get much water. So you kindly concentrate here, Annanagar, Korattur, Ambattur, subsurface medium is clay. For up to top 30 meter, I am telling you want to get some hand pump water. Ainavaram and Madhavaram, it is sand. Vadapaini, Kodambakam, top sand followed by clay. T Nagar is completely clay. So Gindi side of it, I already told you, West Mambalam and all hard rock area. So Velachery is a marine clay, which I am showing. Marine clay with it. This is below which there is a hard rock. So how much a hard massive rock, how much water it will give? That is the reason there is a struggle for water. We get water through the tanker and pipe supply. Now in the clay area of the Annanagar, Korattur and all that, water won't penetrate much. It will stagnate like that. So it has to seep in. It is the water, the underbearing formation should be porous. But unfortunately, clay area in Korattur, Ambattur, Annanagar and T Nagar, so it is not porous and permeable. The water will stagnate like that only. So this is the scenario in Chennai. So some of the dunal complexes, they in the very silver lining in the dark cloud. The Tiruvanmiyur and further Akkarai area, below the subsurface is the dune. in Chambakam, there is a white color sand. You see, white color sand, glass sand is occurring. They hold good amount of water. They are all called Akkare aquifer, silica sand aquifer, where subrounded grey to white color. A white color sand is occurring below the top dune. All your, VGP and all that, all your play theme park. So below which there is a lot of groundwater zone is there. It was there once upon a time. Well, now all groundwater must have been sucked also. But it is a horizon, silica sand, glass sand horizon is there. So that was holding the water. So that was the scenario for the Palar to Chennai to Palar. The second segment is from you see here the Palar to Pondicherry. Further down south we have come. The Palar from the Palar river, from Kalpakam to Pondicherry. The ECR road you would have travelled. Kalpakam to Pondicherry, there is a very peculiar, special geographical and geological situation. It is a dense forested, you would have treated. It is a pleasant to go through in the ECR because the underlying formations are having, I just told you, is called Coromandel elevated mont type, you would have noticed, where you get a thick sequence, a 2 to 3 meter or even 5 meter, a glass sand horizons are there, a silica sand, a porous granular horizons are there. They hold a good amount of water. So parallel to coast, you have good quality groundwater is there in the Mudaliyar Kuppam, Agarama, parallel to coast in the Idekari Nadu area formation in the Marakanam area, north and south of Marakanam, you get a good groundwater potential along the coast. This is apart from the sand, apart from the dunal sand, little bit inland where the ECR road is going, you will pass through this, the glass sand zone. It is being quarried also. A mond is there, dense vegetation. It has got a good groundwater potential. So the satellite imagery I am showing of the Idekari Nadu formation, where you kindly see the cursor. So this is the ECR road. It is going. You get the morphology of some dunal, then the lagoon and the tidal flat. When we get into that, you get a large low mond of the water potential area in the Marakanam north and south area. So this is that. So we can map like that also. Now the third from Pondicherry to Adramapatnam. Now we will travel all along the coast. What is the groundwater scenario? So we have classified the entire coastal into different segments. We are in the third segment now. The first two segments we discussed just now. Now the third segment, what is the tentative situation? From Pondicherry further down south up to Kadalur, then into Chidambaram and in the Nagapatnam up to Adiram Pattukottai and Adirampatnam, this segment. Kindly watch the cursor below in the map I am showing. Now from Pondicherry to this Adiramapatnam area, this segment. So it is a fluid Kaveri Delta. The Kaveri Delta, but you get a underlying below a good kind of, kindly recall the earlier slide I showed you, a red colored sandstone I showed you. In Pondicherry Kadalur. The Neyveli is of such area only, where you get very good amount of confined groundwater situation and semi-confined groundwater is there. So Pondicherry is well endowed along the coast, Kadalur is well endowed, and in the Chidambaram, Nagapatnam, it is occurring at a deeper level. So and maybe a little bit more, more saline in that area, but it is sedimentary. Now the Chennai, Mahabalipuram, that hard rock area is now gone. That rocks are not occurring. Here in the Kaveri Basin area, from Pondicherry onward, we get sediments. Sediment, sandstone, shale, clay stone, siltstone. So the sandstone and the limestones are dominating in the Pondicherry to Vedaranyam and Pattukottai area. They are on the unconfined and confined aquifer you get. So kindly this is for, you remember in Araval Plateau, this kind of sandstone plateau in Kadalur and this one, the Neyveli situation. Neyveli is a bit away from the coast, but still that kind of system extant in the coastal area. So all the sand plateau we go down, where below the lignite seams, there's a good amount of sand, where huge amount of water is there. Daily they are pumping out the water to mine the lignite. Water is surplus and in a confined situation, artisan condition, it is flowing. People are mining to mine it. They have to pump the water, otherwise they cannot mine the lignite. It is pumped out and given for agriculture and even to Chennai city also. So this is the sand horizon in the old sandstone sequence, sedimentary sequence below lignite, little bit above also. So this kind of sandstone aquifer in the Pondicherry and in the Kadalur and further down south, holding good amount of water. A block diagram showing a delta underlined by the sedimentary sequence. So you will get a delta in the Nagapattinam and in the
Sir,
weather area. Yeah.
hello,
Yes.
sir.
Yes.
Okay, sir. It's over. Session.
No, no, it is just going, madam. I need another 15
Yeah,
minutes.
sir. Okay, okay, sir. It's going well, sir.
Huh? Hello?
Good, sir. Going good.
Okay, okay. Are you all able to hear me?
Yeah, sir. It's okay, sir. PPD and voice, everything is okay.
Boys, okay, okay. I hope all are getting benefited. The knowledge goes, then I am happy. Okay. Thank you, thank you.
Okay, sir.
So,
Yeah, sir.
so this is a delta situation I am just showing you. So, superficially you will see a scheme of fluvial, sediments and all that, and marine sediments will be there. Below which a good amount of sedimentary sequence, where only it is being drilled for oil also. Other than the water, oil also being drilled here. Even for kilometer thick sediments are there. 2 to 3 kilometer, 2,000 to nearly 1,000 meter of sediments along this one. We not only get groundwater, we get some oil also in the Nagapattinam and the Karakal and further down south up to Ramnad Basin. We get lignite, we get oil, we get groundwater because the good sedimentary sequences are there. So it's a deep confined aquifer system, unconfined aquifer system where the sediments are interlayered, fractured, a old aquifer system. Now we are on the fourth segment of the Tamil Nadu coast. So you see, now after the Nagapattinam and after the Vedaranyam, we are now in the fourth sector. Kindly see the key map where my cursor is there. So we are running from now the nearly after Vedaranyam, Adhiramapatnam to Thuthukudi. Adhiramapatnam, Thuthukudi, Tondi and Rameswaram, Ramanathapuram and Thuthukudi. This segment is Ramanad, Tuticorin and in the Tondi area. Tamil Nadu coast. How it is hydrogeologically it is there. What is the groundwater potential? It is on a fourth segment. It is certainly different from the deltaic situation. It is different from the Chennai type of situation. But it is where you will get some immediately down south of Adirampatnam. You get some warm water springs, artesian wells. Water flows automatically also. So this map you see, the satellite Google map I am showing, where it is the Vedaranyam, Muthupet lagoon and all that. Here you see a number of transverse lines going. Here this is the Vellar river. So Manamel Kudi and all that. Here a self-flowing, a artesian well, Peraurani, it came in newspaper also. Water starts flowing on because once again you see the deep yellow color sandstone sediment. They extend into the sea also. They extend into the coast below. So automatically when someone drills, artesian wells comes. And it seeps also. And some are warm water also. You may be surprised, sir, Tamil Nadu, sir, where is the warm water spring? So the warm water springs are there in this Peraurani or Tirtharaipundi area. Oh, 40 degrees Celsius or 50 degrees, 60 degrees Celsius it will be there. Then self-flowing. This is the only place where you get some very near the coast, warm water, the artesian wells will be there. Then when we travel down south below, the situation totally it changes. It is becoming a bit of pessimistic, yeah, kind of worrying point from the groundwater point of view. It is a major saline belt. From Tondi to Ramnad, Ramnad to this one, a saline groundwater will be there, saline soil and groundwater will be there. Because of the inherent marine clay, inherent black cotton soil and conker sediment. So, but in the Rameshwaram area, you get some calcareous rocks are there. So about that, the black cotton soil and all that, we will see in a bit more detail in the following slide. So we will now see the last segment. We will now see the last segment. This Tuticorin to Kanyakumari. Now Thoothukudi, up to Thoothukudi we saw it's a black Thoothukudi to Ramnad area, it's a black cotton soil area, Kankari area where the more salinity of the groundwater is there, deeper aquifer may yield, but on the south side we get this kind of a red color terry dune will come. red color. Kindly see the cursor. Red terry dune complex. Well, the coastal dune will be bit inland, deep red color by oxidation, older dune. Below which you will send some calcareous limestone, crystalline limestone. So there is a limited groundwater potential is there from Tuticorin to Kanyakumari. In the calcareous situation, calcareous crystalline limestone, there's a hard, again the hard metamorphic rock comes. I am kindly see my cursor in the map, the last segment Kanyakumari to Tuticorin. So you get some old, red colored terry sand, which is also can hold some groundwater. Then underlying the calcareous gneiss and the limestone rock, you see the fractures and bedding in that. So they also hold as moderate amount of water. The unconfined aquifer system exists. So these are the broad five type of entire Tamil Nadu coast I have narrated how the situation. Now in the next 10 minutes I will finish. We will now see the management. Now how the groundwater, because the whole issue comes. Now we know where it occurs, how it occurs we saw. Along the Tamil Nadu coast we saw how it occurs, where it occurs. Now we see how it is managed. Now, now we see it is a contain exploit, groundwater is exploited more, and they are telling only 6%. Rainwater is also less, and it is only going into the ground also becoming lesser and lesser. Yeah, exploitation becoming more. So this is very commonly understood point, and so many too many boreholes are drilled very close. So நம்ம வீட்ல ஒண்ணு பக்கத்து வீட்ல ஒண்ணு அங்க ஒரு agricultural bore இங்க ஒரு agricultural bore. So it is so much is withdrawn. Exploitation. If it is ideal to exploit the 70% of the aquifer water only, but we are sucking 100% or more. Now, because of that, along the coastal area, a salinization or seawater intrusion. Seawater intrusion takes place North Chennai in the Minjur and area, Ennur area, as well as the south side. I just told you in the Ramanathapuram, in the Tuticorin area. When we dig more bore, you see here when we put borewell into the marine formation and the underlying sediment, there is a cone of depression. There is a water being more water sucked in, and the sea water slowly enter. The sea water enters because of the cone of depression. You see, this is the interface between the salt water. Sea is here. This is the salt water. This is the fresh groundwater. This interface slowly moved. Follow my cursor. In the online class, the cursor is, watching is the most important. Understand the diagram. This is the sea. This is the land. The contact between fresh water and the sea water, it is slowly coming in, because we are putting more borehole in there, drawing fresh water. You see here the fresh water is sucked more. So with the result, the sea water is coming in and all that. So salinity takes place. So in the Tamil Nadu coastal base, Pumbukar area is saline, little bit Navapatnam, then this Tondi and in the Ramnad area saline. A map is prepared like that. Now chemically we analyze also the conductivity TDS. Total dissolved salt will be very high. But when compared to a potable water, the salinity starts when it is more than 3000 milligrams per liter. The sodium and chloride, the chloride and sodium value also will be very high. You see here. So we have to chemically analyze and see the water. Now, this is the Vaigai area. Vaigai river debouching into Mandapam and Rameswaram. You see a paleo delta in the satellite imagery. Remote sensing plays a wonderful tool. Don't have a very good aspiration that it is a delta, sir, we will get more water and more saline, sweet water, but it is more saline. Around Vaigai Delta and northern side, you see a black color lobe here, another lobe here in the Ramnath, then south in Thoothukudi also. So it's a low flat plain where a salinity is more. Again, a geomorphological map is prepared. We mark as dune and and the other tidal flat and all that. We mark the saline zone here. A map is prepared where it is hypersaline, where it is less saline and all that. Now in the Ramnad and salinity problem, let us discuss a little bit, because the marine formation on the inland, it is controlled by former sea transmission. The sea has come in the past geological period number of times inland. The transmission took place, inundation of the land number of times in the past. Oh, so even in the future also it will take place by sea level rise. But in the past there was a sea level rise. There was a number of times sea has come in and deposited this marine clay, silty clay, and sand was deposited multiple times. Repetitively sea has come in the past, and there was a marine inherent marine formation deposited. So below Ramna, in the Tuticorin also, there is a calcium gypsum rich marine clay. There is a black cotton soil development, calcrete. This clay and black cotton soil and marine clay, they won't allow the water to go in. When the drainage water won't get into that, there will be a more stagnation, there will be more evaporation, more salt deposition, and more salinity. Soil and groundwater cell, these are reason. Inherently, there are past tree transcription, marine shale, marine clay, and silt, and all that have been deposited in the Ramnad and the to making the water more saline. You see here, kindly see the picture, a black cotton soil and a marine clay where gypsum and other calcrete nodule, they are all clayite. Where you cannot, only cotton is grown. We cannot have much irrigation and all that. You drill also, you won't get much water. So, cause of salinity, so some are induced. For example, Chennai, it is a induced salinity by human being drafting more water, the seawater comes in. The seawater, salt water comes in, North Chennai, Thiruvanmiyur and all that. But inherent salinity, inherent subsurface, the natural, the geological formation and all that, in the past sea incursion in the 6,000 years before present and 1,24,000 before present. So geomorphology is critical in mapping the past sea level. Where are the past marine formation, marine clays? That gives the salinity. So geomorphology is critical. All geographers understand that. So geologically, old marine sediment contribute to salinity. So other than the salinity problem, the groundwater is, with a lot of industry in Chennai, Kadalur, Thoothukudi, and domestic and industrial contaminant, chromium, cadmium, fluoride, and all that, Salem, Marana. So along the Tamil Nadu coast, we may get some chromium and all that in the tannery industry area. So, but the Bengal, coastal area got a lot of arsenic. So iron is more in the Chennai itself. The underground water is more iron rich in the Alwar Nagar area, KK Nagar area, Coimbatore area, where water is more in iron. When you keep in a pot and see after some time, it water will become more red. So it's a very iron rich. So iron is the problem, arsenic problem. Salinity we discussed. You get chromium and all that because of the inherent, industrial use and industry and by our regular, natural contaminant. So most of the dunes and all you see, we are the holding water. I told you in Thiruvanmiyur and Akkarai, Aquifer and all that. Even in, all along coast, these dunes hold a good. But we are degrading the dune also. Road laying, housing, urbanization. See, this sand gives the water along the coast, little bit whatever. They are also being eliminated slowly. Where we will get water, there is a degradation, dunal degradation takes place. So water table continuously depleted and going. So out recharging now, management of the groundwater. Now we have to recharge it. Rain recharges. If the rain is insufficient, we have to recharge it. How? First of all, it is a school knowledge. All the rooftop rainwater to be stored. Rainwater harvesting. There is a recharge to be done. Water has to seep in and go into the land. In urban area, concrete jungle, more overflow surface runoff. In stormwater drain, it is going waste into sea. It should be going to the ground, see the rainwater harvesting, each house should have. Then, on a larger way, we can construct some check dam. Now, from this slide onwards, in another 3-4 slides, what are the recharging methodology we can now see. We can construct a check dam. We can so that the water is stored and percolate into the ground to raise the water table level. Water table level is going down and down. We have to make it up, or we can pump water into aquifer so that the water table level go up. From other outside source, pump water into a scarcity area. Put more water. This is in addition to rain. Now the rainwater is becoming lesser and lesser. We have to now either stagnate pour water, percolation pond. We have to construct this kind of dam and check dam and percolation pond, allow water to get in. Or we can have, even in ancient kings, the Kudimaravati. Number airy tanks, we have to, desilt, make it more store water. Here in the upstream hilly area also a recharging, canal we can dug, recharging canal, you see. Watch my cursor, the water should go in. This stormwater drain in Chennai city, they should design in such a way it is stored in some other areas of pond and gets into the ground. Otherwise, all through the city, whatever the road water and the street water, every water, a concrete lined storm water, it goes into the sea. We have to make the water, rainwater to go in. So we have to identify such area where the recharge can be done. So it is a special subject. It needs a separate lecture. So recharging is this one. So this is the last slide. So I have discussed the groundwater basics. As a summary, the groundwater, what are the aquifer type, where it can occur, what are the rock type, what are the porous and permeability, how it can fracture along the Tamil Nadu coast, where it can occur, what is the potentiality of each segment. Chennai Mahalveram segment, Mahalveram Pondicherry, Pondicherry, Vedaranyam to Thoothukudi, and Thoothukudi to Kanyakumari. We saw the segment, their potentiality, the subsurface medium water bank material, and finally some management issue we saw by recharging with some check dam and stormwater drain and other artificial recharging system. So this we saw. The finally, my grandfather saw the water in river. Father saw it in the well. We saw it in the tap. Our children see it in the bottle. Grandchildren see it in the capsule. We can only see it in tears. In the future, it's going to be tough task. So very critical situation going down. Let us pray for more regular, systematic rain. What we saw in our younger days. If that is there, somehow we can manage it despite our growth. Thank you very much. Thank you so much. Thank you. Hello, madam.
Yeah, sir. Thank you, sir. Thank you very much for your presentation. Is very nice, sir. So, a lot of participants saying that that is a very nice sessions, nice, very informative. Like that, they are putting information, sir. Sir, now the question session, sir.
Yeah. I can answer.
Chat, sir, can you see the chat box, sir?
Pardon?
Chat box,
Yeah, I
comment
can
box,
start.
sir.
Yeah, you can start. You can start. Any questions?
Yeah, some of
Any
question.
question? You can read if it is there in the YouTube.
Sir, one question is there.
Okay.
Uh, Please say national level segments which has more water table and the states which has
Pardon?
good water table.
Pardon?
Hello,
What?
sir. Please say national level segments which has more water table and the states which has good water table.
National
Uh,
level?
segments
Ah,
segments which has
ah.
more water table and the states which has good water table. Professor K.
No, that is why. See, it is not a uniform. Some areas are, some are rich, human beings, some are rich, some are poor. See, some are very healthy, some are weak. Like that, some areas are healthy for groundwater potential, some are weak. So, suppose, for example, even in the Tamil Nadu coast itself, we told some area, for example, this, Pondicherry, Kadalur, and all that, they are good in groundwater. But some are poor. The Ramanathapuram and Tuticorin and all that groundwater problem area. So it is not a uniformly available everywhere. It is some segments. That's the main reason for all our earth scientists to locate a good groundwater point for the society.
Sir, next question, sir.
Yes.
Lokamani Mohan Raj.
Uh,
Uh, have a question. After the monsoon season, the groundwater level in Coimbatore district rises in winter only, sir. And I want to know whether this much time to take or not, sir.
No, no. In the Coimbatore, what is the problem?
If there is, so wait.
In the Coimbatore, what is the question?
After the monsoon season,
Uh,
the groundwater level in Coimbatore
uh,
district
uh.
rises in winter. Coimbatore district rises in winter only, sir. And
No,
I want to know
uh,
whether this much time to take or not, sir.
no, 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 no. See, it is a the water table incrementally it rises as and when it is recharged either by rain or by artificially. See what whether any aquifer or any well, when we see below, whenever there is a rain, there is a gradual increment will be there. So today, suppose we see today, it won't be overnight. Today evening, it won't increase. It is not like a pouring in a pot. There is a subsurface flow of water. Water comes from somewhere to each area. There is underground flow is there. For a Coimbatore town, the underground groundwater flow, there is a catchment area is there. Catchment area will be far away from the town. So that is the reason all the water falling in the catchment area, slowly flowing below, get into the soil and rock, then it enter into the wells and aquifer. So certainly it will take some time, and as and when rains, it gradually improves.
So now one question, sir.
Yes.
Faisal, if there is not a technology in village areas like remote sensing and GIS method, then how to locate groundwater location? Is there
Huh?
any other method,
Groundwater,
sir?
forget the GIS remote sensing has come recently only. They are only the initial tool. Remote sensing is not the answer for all our groundwater search or the mineral search or any study. It is just like before going to marriage, seeing a girl's photograph. The satellite imagery remote sensing is only a cosmetic. In the beginning stage, one has to use. It is not an end in itself. It is only a means to an end. It is one of the tool. From the remote sensing, satellite imagery and GIS, from the satellite imagery we get some initial clues where some potential will be there. Then we have to go down into the ground, see the geology of the area, break the rock and all that, see all the well, then conduct a geophysical survey, pass electricity into the ground, restivity survey, because whenever there is a more water, water is more conductive. So where is the more conductive area we have to see. So restivity electromagnetic survey, then only the drilling will be done. So water location is a big exercise. Remote sensing is not the only exercise, it is one of the two. Next.
Sir, how we are getting sprinkler? What is the process behind it, sir?
Pardon?
How we are getting sprinkler?
How we are getting?
Sprinkler.
I am not able to. How we are getting?
Sprinkler, sir. SPRINKLER.
Sprinkler. Sprinkler, no, springs, artesian spring.
Ah.
Yeah. Self-flowing well.
What is the process behind it?
See, in one of it is causes is I told you when it is under pressure, anything under pressure, you squeeze something, it flows out. You squeeze a banana, it flowing out of the hand. When the water is held under tight pressure at the subsurface, a porous rock, sandy aquifer, it is confined above and below. There is a pressure. Now, when you put a well or drill it, automatically it flows out. In Neyveli, there's a situation. The pressurized groundwater system at the subsurface, it flows out. When Chennai and all that, it is not a pressurized system. It is an open system, unconfined. It is an unconfined aquifer. In a confined aquifer, the springs and flow will come. Whenever this confined aquifer meets the ground, there will be some springs, artesian spring, artesian wells. So you need a pressure system like a Neyveli and in Adirampatnam, Peraurani, some segments we have such a system. Next.
Sir, one more question from Kamani KK. In our India, which regions are rich in groundwater table? Say states of the country of rich water table.
Huh? What? In
our sir, in our India, which regions are rich in groundwater table?
Which regions are in
groundwater table?
Which is groundwater table? Groundwater rich zone.
Yeah,
or
sir.
poor zone. See, kindly understand the
Rich
concept. Water table, it is water table is just a top surface of the water we see in the well. It is a level of the water below the ground, below our foot. So whether it is deeper or at a higher level or at a lower level. So in some area it will be at a very deeper level where Rajasthan desert. Since the question is on nation, I will tell you that. In the Rajasthan desert, it will be very deeper and deeper because less rainfall, aridity. Yeah. So, but in the Ganges plain, where it is more rainfall and snow melt runoff, it is at the subsurface area only. Uttar Pradesh and Bihar and all that. So it is in India, some area the water table will be at the top level, some area it will be at a lower level. In the desertic arid place, it will be at a deeper level. In a very high rainfall area, Kerala and other Karnataka west coast, it will be at a upper level. Next.
Sir, one more question. If groundwater is contaminated, whether it can be rectified, sir?
Groundwater is contaminated by yes. It is a we have to very good question. This is a question of the day. Question of the day is this question. The groundwater is contaminated. What it can be done? So, for example, some groundwater is contaminated by arsenic. Some groundwater is contaminated by lead, cadmium, iron. Now, some elements are separable. For example, iron in Chennai and all that, in Alwar, Srinagar, Coimbatore and all that, the groundwater is, the iron is removed by a kind of filtering process and all. But it is complicated to remove arsenic lead if the area is contaminated. Because in a small tank we can do chemically, we can take the lab and the element can be, it is a elemental mixing with the water system. So,
sir, hello.
Some disturbance. Okay. So but it is better to avoid. It is better to avoid the contaminant getting into the groundwater. It is not. It is a very difficult to remove a major contaminant like arsenic, lead, or cadmium, and all that. Once it is spoiled, it is very difficult. No. We have to treat the effluent. We have to treat it and send it to the ground. Otherwise, it will be deadly, and we will all be affected. Ecosystem will be affected. Only some are removable. See, sodium chloride and all that salinity can be desalinization. We can remove. Saline water can be made a good water. Iron water can be made a good water, but not arsenic and cadmium, lead, chromium rich water. Not possible. Easily. Small amount we can do. A big system, a big groundwater, it is difficult. Better to avoid the contaminant. Next.
Sir, what is the impact of injecting seawater into geomorphological sites?
What is the impact of seawater?
Into geomorphological sites. Can the environment itself solve the water problem in that site? By environmental action, what is the influence of weathering? Can I read once again, sir?
What is the influence of?
What is the impact of injecting seawater into geomorphological sites? Can the environment itself solve the water problem in that site by environmental action? And what is the influence of weathering?
What is the influence of
Weathering.
weathering? No. See, I told you in that slide, the seawater slowly coming into the inland and all that. So it is encroaching into the fresh water because density level of the seawater is very high. So it comes on. It is encroaching so forcefully. Now, where the seawater will come in automatically, seawater intrusion, where we draw more fresh water, over extraction, I told you there is a cone of depression forms when more fresh water is exposed. For example, Chennai itself, we go on, pump the good water, automatically the aquifer becomes empty. When the vessel is empty, the adjoining seawater will try to occupy that. So that is the seawater. Then another point, another way of seawater is originally it is remaining there by inherent marine sediment which have been deposited there long ago, millions of years ago. So that area is groundwater. So seawater intrusion by salinity of that area in any geomorphic unit, whether it's a sand or a clay, it is or in the adjoining hard rock. It depends on our utility of the system, and the best way is to arrest that by our controlled usage of the good water, and desalinization is the best aspect for that.
Sir, one more question, sir. Anand and Kalanivel. Borewell in the farm pond will reduce salinity hazard. Borewell in the pond will reduce salinity hazard.
Which one?
Borewell in the farm pond will reduce farm pond. FARM POND, sir. Farm pond will reduce salinity hazard.
Borewell in soft rock.
In the farm FARM, sir. Farm.
I'm not able to understand the question. Borewell in
the farm FARM farm. Pond POND.
Borewell in farm. That is agricultural farm.
Farm, maybe I think so, sir. Pond will reduce salinity hazard.
Borewell, anywhere you drill, it depends on the subsurface. Good water, it will give good water. But brackish water, brackish. Saline water. How it will solve the salinity? Yeah, what she is asking, I told you. Yes, to some extent, we can bring water from outside in the saline zone. Oh, now I understood her question. We can recharge. We can put some good water into the saline water system and dilute it. So that is a very costly and ill-advised. Only if there is a very good rain in the saline area, that will dilute good water go into the system. What the viewer, the candidate or student is asking, suppose we put through borewell some pump fresh water into the saline area, whether it will be solved. That's also a good question. Very good question. No, it is not at all advisable. Only a rain will solve it. We cannot pump the recharging. We cannot do in a saline area. Recharging we can do only in a good area.
Sir, one more question. Lokamani Mohandas have a question. How the thunder wells are happening, sir?
How the
thunder wells are happening, sir?
How the wells are?
How the thunder wells.
Contaminant.
Thunder, sir. THUNDR. Thunder wells.
TH. Pond. Then what is the another question?
Thunder wells, sir.
Concur.
Thunder, sir. THUNDER.
Thunder. How the thunder?
Wells. Thunder well.
Well. Thunder is a noise, and thunder, the rain, thunder, lightning.
Yes, sir.
It is not related to groundwater.
Okay, sir. Thank you, sir.
Thunder and groundwater is nowhere related. Thunder is atmospheric phenomena. It is not
Sir,
real.
only this is the last question, I think. Sir Mitra asking a question. Basically, which type of rock consists of more quantity of groundwater available?
Which?
Basically, which type of rock consists of more quantity of groundwater available?
Which kind of rock available groundwater? I told you only granular rock, sandstone. Anyway,
Okay.
sand, river sand. So more sandy, more it has got more porous, more void space, more porosity and permeability, more pervious. Water will move, water will get in. So more the porous, better the medium. In a hard rock, if the rock is more weathered, it is made to more porous with some cracks and fractures. It will be more congenial for a good groundwater holding system. So the rock should be broken into pieces. Rock should be porous. Then it is good. Sandstone is the ideal medium. Sandstone is a good aquifer, not only for groundwater, for oil also.
Yes, sir. Question is over, sir.
Thank you, thank you, thank you.
Sir, now the end of the session for vote of thanks, sir.
Okay,
Yeah, sir, we are really lucky to listening your lecture, sir. This is very grateful and very very informative, sir. Thank you so much. And audience also very lucky persons to listening this session because it's very very informative and interactive, sir. Very clear PPD also, sir. Thank you so much, sir. Thank you
thank you,
for your accepting and coming to sharing your knowledges to participants and the conveners, sir. Thank you so much, sir. On behalf of Bal Women's College and Satyabama University, we thank lots, sir. Thank you, sir. Thank you so much, sir.
thank you very much. Thank you. So kind of you. Thank you very much. Thank you.
One note, one information for okay, sir. Thank you, sir.
Can I exit the meeting?
Yes, sir. Thank you, sir. Thank you so much.
Okay.